All right, got going before I wanted to record this. So what would we call this? This is section 2.1 review, right? So that's worksheet. And these are the problems that we're going over. All right, so we're doing this problem right now. We subtracted 1 from both sides. If I subtracted 1 from this, it's 10 over 10. Everybody with me? All right, so let's see what we get. So 1 minus 1, 0, cancels out. Bring down this. It's negative 5 over 9x. Notice where the x is. This is very, very important. Where is the x here?
Right there in the denominator.
It's in the denominator, okay? That's a big difference than a lot of the problems that you've seen before. A lot of the problems, the x is in the numerator. It makes things a little bit easier when it's in the numerator. This makes it a little bit tougher when it's in the denominator. So remember where it is. It's not just negative 5/9 x, is it? All right, it's negative 5 over 9x. That's very, very important. Okay, equals, now what's this going to be? It's going to be 8/10 minus 10/10. What's that? Negative 2/10. Good. So that wasn't so hard. All I did was subtract 1 from both sides, right? So you go home, your parents say, what'd you do in math today? Well, I just subtracted 1 from both sides. That's all I did. Okay? And that's technically all you did. What are we going to do in here? I want to get that x by itself, don't I? I don't want to keep it. Let's just keep it over here on the left-hand side. So I have to get rid of this negative. You could consider this being a negative 5 positive 9 or a positive 5 negative 9. It doesn't matter. Or you could just think of this as this. Watch, you got a negative on this side, you got a negative on this side. You know what might be the easiest thing to do? Just multiply both sides by a negative. What will happen then? They both become what? Positive. Then I don't even have to worry about it being negative anymore, don't I? Everybody see that? Anybody think about doing it that way? It's kind of a nice way to do it, isn't it? If you have negative on both sides, right? Just multiply both sides by a negative or a negative 1, and they just both become positive. So now I don't even have to worry about negatives. So that helps me out a little bit, doesn't it? So what do I have to get rid of now? have to get rid of this 5, and I have to get rid of the 9. So how in the world am I going to do that? Well, look where the 5 is. 5 is on top. So how do I get rid of it if the 5 is on top? Put it where?
Bottom.
On the bottom. So they do what? So they cancel out. That's right. Everybody see that? So if it's a fraction, and it's all just multiplication here, okay, there's nothing being added or anything, right? If the 5 is on the top, I put it on the bottom, they'll cancel out. What about the 9? Where's the 9 right here? It's on the bottom. So where do I want to put that? I want to put it on the top. Why? So they cancel out. Basically, what did I just do? What's the fancy math phrase that I've been using? We multiplied by the reciprocal. That's really what we did, isn't it? Do you understand why we multiplied by the reciprocal? Because it cancels the stuff out, right? That's the whole idea. We want to get rid of that 5/9. So cancel out the 9s, cancel out the 5s, they go away. But I can't just do that to the left side. I got to come over here to the right side, do the same exact thing. So what is the same exact thing? Multiply by 9/5. Everybody good with that? All right, not so hard. So basically we've done two things. We subtracted 1 from both sides, and then we multiplied by 9/5 on both sides, multiplied by reciprocal. So we've only done two things so far, and we're almost there. But look at that x. Again, I'm going to ask you again, where is that x? It's on the bottom. Okay, look, when I say these canceled out, they really divide out to be a 1, didn't they? Right? And then this 9 and this 9 went one time. So what's on the top here? This is not just an x here by itself, is it? What is it? It's a 1 over x. That's very important. Man, I've seen it over and over and over again every year when I teach algebra, that if we have a problem like that, if x is on the bottom, people just think, oh, the left side is just x. Everything canceled out. I just have an x on the left-hand side. No, I don't. I have a 1 over x. That's a lot different. Okay? Equals. What are we going to do here? Does anything cancel out real nice? Yeah, I do see one thing that cancels out. What do you think? The 2 and the 10, right. So 2 goes into 2 once. 2 goes into 10, what? 5 times. Does anything else cancel out? No, so let's multiply. What do we get? 9 over 25. But that's not our answer, is it? X doesn't equal this. 1 over x equals this. Do you remember what we did last time we did this problem?
Flip it.
Flip it. Very good. Look, 1 over x. Remember, whatever I do to one side, I can do to the other side, can I? So what am I going to do? I don't want 1 over x. What do I want? I want just x, or x over 1, don't I? Okay, and I can do that. I can take this side and just take the reciprocal of it. I'm not multiplying by reciprocal. All I'm doing this is flipping it. So instead of 1 over x, I can make it x over 1. But I can't just take the left side and flip it. Remember, whatever I do to the left-hand side, I have to do to the right-hand side. So what am I going to do to this fraction? I'm going to flip that as well. And that's my answer right there. Okay? 3 steps. 3 basic steps. Okay? This is our first step. Was what? Just subtract 1 from both sides, right? What did we do here? What was all that mess? So there, all that stuff marked out and 1s all over the place. What did we do here? We just multiplied by the reciprocal. Okay, that's our second step. Agreed? Then we got this thing right here. This was our third step. That was probably the easiest step, wasn't it? Flip this, flip this. Whatever you do to one side, you can do it as long as you do it to the other side. So if I flip the fraction on the left-hand side, I can flip the fraction on the right-hand side. Bang, I'm done. 3 steps and I'm done. So if this is on the quiz tomorrow, everybody's good with this then, right? All right, this is the second time I've done this in front of you guys, all right? And you were supposed to, now I know I see some of you writing down, that's great, but you're supposed to write every step down so that you can look at it, look back on it and review it. Okay, enough of that. Gotta go back up to the top again. What do we have? 9, 12, 10. Let's go 10 and then we'll go 12. Is that all right? So let's do number 10. Oh, okay. This should be fairly straightforward. So I'm going to go a little bit faster. I'm not going to take as much time to explain stuff on this one. All right, here we go. It says to solve. Well, there's only one variable here, so it's obviously what we're trying to solve for. We're going to solve for p. So hang on tight. Here we go. Negative 5p minus 2. This negative 3 is being distributed, so that's what I'm going to do first over here. So it's negative 3p minus 3. Don't forget, negative 3 times positive 1 is negative 3. Distribute this negative right here through this parentheses. So that gives you positive 4p plus 2. Easy. Couple distributive properties. Let's add up all our like terms. Let's simplify the left side and the right side. Well, what can we do on the left side? Negative 5p minus 3p is negative 8p. Negative 2 minus 3 is negative 5. All I did was just add like terms. The right side, there's nothing I can do to add like terms because it's all simplified. Now I have to get the variable on the same side. You could take the 4p and put it on the left-hand side if you wanted to, or you could take the negative 8p and put it on the right-hand side. I'm going to do this as if I was actually doing this myself, okay? If I was personally doing this, I would add an 8p to both sides. We talked about that the other day, didn't we? Why would I want to do that? Why would I put it on the right-hand side? Yeah, it just makes it positive. I don't know. It just makes it a little bit easier for me. You don't have to worry about that negative floating around. All right. Now, if I put the p's on the right-hand side, I want to put the constants on the left-hand side. So I'll do that by subtracting a 2. All right, so what canceled out? Those canceled out. These canceled out. Let's bring everything down. You got to know how to do your arithmetic on this. Some of you guys are just not knowing how to, excuse me, do basic addition and subtraction with negative numbers, okay? As much as I hate saying this, and I really hate saying this because you should be able to do this in your head, but if you have a problem with this, if you are struggling with adding and subtracting with negative numbers, sticking them in a calculator just to get the problem right. You really should learn your rules, okay? But if worse comes to worse, okay, if you're on a quiz or a test, put them in your calculator, all right? Almost hate to say that, but I want you to get the problems right. Negative 5 minus 2 is negative 7. And then this is 12p when I add those together. Divide by 12, and there's your answer. P equals negative 7/12. Don't put that into a decimal or anything else. Just leave it like that. All right, that was pretty straightforward. That was your basic Algebra 1 style problem right there. So maybe if you got it wrong, maybe you just did a little arithmetic error somewhere. Hopefully that's what the problem was. Hopefully it wasn't that whole idea of distributing and adding like terms and all that kind of stuff. Because it was, that's a bigger problem. All right, if you just make a little computational error, I do that all the time. It happens. All right, but hopefully you know the whole structure of what we were trying to do there. All right, what was the next one? Was it 12? Did anybody write those down? Okay. All right. Alrighty.
We did this exact.
We did the exact same one? Well, good.
Yeah, 'cause that will not.
I'll go kind of fast on this then. All right, what do we want to do? We want to get the p's on the same side. Agreed? So let's do this. For the same reason, now I could subtract this p from both sides, but that will make this a negative, right? Because 3/5 is smaller than 1, isn't it? So if I go something smaller minus something bigger, I'm going to get a negative answer. So I think it might just be easier just to do this. Now look, I'm not just getting rid of the 3/5 though, am I? I'm getting rid of the whole entire term with the p in it. I have to get rid of that whole thing, not just the 3/5, because I want the p's, the variables, on the same side. So I have to move the whole entire thing over to the other side. All right, I'm not just getting rid of the 3/5. If I just get rid of the 3/5, I still have a p on the left side and still have a p on the right side. That's not going to help me. Got it? Okay. So that will cancel out. That's a negative 12 equals. Now look, we kind of did this earlier. This is like 3/5, isn't it? 3/5 p. What is this? That's a 1p. So what if it was 1 minus 3/5? What would I change that 1 into? So if I'm going over 5, right? What am I going to make 1? What over 5 is equal to 1? 5 over 5, right? So watch. Let's write it like this. Let's write it 5p over 5. Isn't that the same thing as 1? Yeah, you should be able to do that in your head, okay? This is just taking a 1, which is the easiest thing, and just making it so it has a denominator of 5. What over 5 is equal to 1? 5 over 5 is equal to 1. So 5 over 5p. So 5p over 5 minus 3p over 5 is 2p over 5. Right? It's just 5 minus 3. Now, if you would have taken that first step and put the p on the left-hand side, you would have had a negative 2p over 5. All right, I don't know. I just think it's easier having it positive. Do you? We've done this once already today. Look, I got a 2/5 and it's being multiplied by p. How can I get rid of that 2/5? What's the phrase that I use? Multiply by the reciprocal, right? So I'm going to do that. Multiply by the reciprocal. That's 5 over 2. So I come over here and I multiply that by 5 over 2. Right? Put that over 1 just so it looks nice. We could just multiply straight across if you wanted to, but I always see if something cancels out. And it does. 2 goes into 2 once, 2 goes into 12, what? 6 times. Remember, it's a negative 6. So now everything canceled out, so it's 5 times negative 6, which is negative 30. And that's what p is equal to. P is negative 30, just like that. Don't they look easy when I do them? I don't know. Do they look easy or do they still look hard when I do them? I think I'm kind of explaining it pretty well. Do you? I think I'm getting pretty basic with it. I hope. I'm trying. I really am. All right. 21 to 23. 21, 2, and 3. All right. Let's use this pink color. All right. 21. All right. All right, this was just, yeah, this was the hardest one, 21, right? Yeah, the other, just plug and chug. This one, you actually had to get something by itself. So it's B, Q plus 1. It's kind of weird looking, but that's a Q right there, right? And that's supposed to be an F. It's Monday. Haven't written all weekend, so. All right, so there's your formula. And what do they tell you? They say find F. Find F. That's what you're trying to solve for. And it's very important that you read the problems and you know what you're trying to solve for here. And they tell you a bunch of stuff, don't they? Let's list all this stuff down here. They say A is 14%. Now that's a percentage. So when I plug it in, now we didn't talk about this the other day, but this is something that you talked about in elementary math, in middle school math, even a little bit in Algebra 1. If I'm putting this percentage into this formula right here, how am I putting it into the formula? Am I actually putting in 14% for that? 0.14, right? You learned that stuff before, didn't you? Yeah. Okay. There are some things that I have to assume that you've learned, and that's one of them. All right. So they tell you that. They tell you what P is. They tell you P is 12. B is 4,900. Little b is 4,900. That's dollars, but I don't care about putting the dollar symbol there. And Q is 12. Now look, you got a couple options on how to solve this. You can put all the numbers in right now if you wanted to. All right? And then try to get f by itself. That's what you're trying to get by itself. That's one option. And that's a legitimate option, okay? But I'm telling you, as equations get a little tougher, if you take, even if you're not taking physics now or something, I'm not much of a chemistry person, but I would think chemistry would kind of be the same way. Sometimes you want to get the variable by itself first. Do the algebra first. Get f by itself first with all these letters. Then at the very end, then you can plug stuff into your new formula. So that's what I'm going to do. I'm going to get f by itself. It's really not that difficult. If I'm going to get f by itself, look what's going on. You're dividing, use a different color here. All this stuff right here is being divided by f. So how do I get rid of something if it's being divided? Come on, talk to me. I multiply, that's right. And this is still like multiplying by the reciprocal, except the reciprocal is a little bit weirder looking here, okay? So if I want to get rid of all this stuff down here, I multiply by it. So I'm going to multiply it by b times q plus 1. All right, so that'll cancel that out. Agreed? Now, what else is left up here? The 2p. Now that's being multiplied, isn't it? So how do I get rid of something that's being multiplied? I divide by 2p. So look, I do the same thing over here. So I multiply by b times q plus 1, and then I divide by 2p. That's my new formula. All right, that's the formula that I'm going to plug numbers into. So let's get f by itself just to make it look real nice. Do you mind if I put the a first? Put a, and then b, and then a q plus 1. So that wasn't that hard, was it? To tell you the truth, I think it's easier. I really do. I promise you. I think it's easier to solve for f with all these variables than it would be if you plug all the numbers in and get these crazy looking numbers, right? I think it's way easier to do it this way. So now, we've got f by itself, so what are we going to do with these numbers? Plug and chug, right? So let's put them in here. So f equals a. What's a? 14%, but what we said it was going to be a 0.14. Times b. B is 4,900. Okay, and then this is q plus 1. I'll tell you what, we can do that in our head. Q is 12, so 12 plus 1 is 13, right? You don't have to put 12 plus 1, do you? You can do that in your head. Over 2 times p. This is another one we can do in our head. 2 times p. Well, p is 12. What's 2 times 12? Just 24. Now, what do you do with all this stuff? Yeah, stick it in a calculator and figure out what it is, right? And I just happen to have a calculator here, so let's use it. So it's 0.14 times 4,900 times 13, okay, divided by 24. And I hope that's your answer. Yep. Does it say round? Doesn't, but we'll round it. Okay, so it's 371.58. If you wanted to keep it like that, that'd be okay. But I think they rounded it, didn't they? 372. Yeah. So 372. Now again, I don't even. I mean, it's in dollars. I believe it is, isn't it? Yeah, it's in dollars. But if you didn't realize it was in dollars, it doesn't matter. I'm not going to mark it off if you didn't put the dollar sign there. Okay, just put F equals 372. If you wanted to round it to one or two places, that would have been fine as well. I wouldn't have marked it wrong if you did that. Okay. Now look, we ran out of time to do those other two, 22 and 23, but it's basically like this, isn't it? 22 and 23. Just plug the numbers in and see what you get. All right. I'm going to let you hang on to that, and I'll take it tomorrow so that you can use it to review. All right. And so we're going to have a quiz tomorrow. I'm not really going to review or anything, so be ready for it. It's going to be the stuff on this worksheet. So please, please, please go over this worksheet again. All right.